The first four figures in the sequence are shown below. Figure 1 is a single black dot, while the others consist of black dots arranged in equilateral manner. Then it says, draw figure 5. Now figure 1 constitutes of just one black dot. Figure 2 now looking like this. This is figure 2. So you add 2 to it. Figure 3, you add 3 to it. 1, 2, 3. Figure 4, you add 4 to it. 1, 2, 3, 4. And to figure 5, you add 5 to it. 1, 2, 3, 4, 5. And so this would be a representation of figure 5. I don't know, it doesn't look that well. If you wanted to make it look better, you could just draw your dots like 1, 2, 3, 4. See, my dots not coming out well anyway. So this is figure 5, where figure 5 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 black dots. All right, so look, figure 1 has 1. Then you add 2 to figure 1 to get figure 2. Then you add 3 to figure 2 to get figure 3. Then you add 4 to figure 4 to get figure 4. And then you add 5 to figure 4 to get figure 5. All right? And so this is figure 5. It says how many dots would be in figure 6. Now looking at it, figure 1 of 1 dot, figure 2 of 3, then figure 3 of 6, then figure 4 of 10, then figure 5 of 15, as you can see here, so figure 5 of 15. So add 6 more dots to that, so figure 6 would have 21 dots. Nice and easy. Now they might give us a table, more than likely. Clearly, we knew. So here's the formula that they give us to find the number of dots. So the number of dots is 1 over 2 times 1 times 1 plus 1. Continue to the train. When it is 11, the number of dots is 1 over 2 times, instead of 3, it's going to be 11. So it's 1 over 2 times 11 times, it's going to be 11 plus 1. That will give us the number of dots right there. When we work that out, it is a half times 11 is 11 over 2 times 11 plus 1, and that is 66. So the number of dots used is 66 right here. All right. Then when instead of using 11, we use n, it's going to be a half times, instead of saying 11, it's now n times, now 11 plus 1. Instead of 11 plus 1, you replace 11 with n, so it's n plus 1. So what is the number of dots working out to be when we expand this formula? It is a half. It is really just a half of n times n is n squared, so it's a half n squared plus n. Half n squared plus n. That is the formula. So now it says complete the row, which corresponds to figure 11. We did that. Then it says determine the figure in the sequence that has 210 dots. Which figure gonna have 210 dots? We don't know yet, but we can set a half n squared plus n equals 210. because this gives us the total number of dots for n figure. So if we set that equal to 200 and n and solve for n, that will give us which one will have 210 dots. So solving this equation, we can multiply through by 2 to get n squared plus n is equal to 420. N squared plus n is 420. Now to solve this equation, the easiest way I'm going to say is to go straight ahead and use quadratic formula. Put it in its standard form, n squared plus n minus 420 equals 0. I would never recommend for you to try to well, you can factorize it, but yeah, if you want, you can factorize it, but I prefer using quadratic formula in this case. All right. So using the quadratic formula in this case, n is equal to minus b, which is -1, plus or minus the square root of b squared, which is plus or minus the square root of 1, minus 4ac, which is minus 4 times 1 times 420, 4 times 1 times 420. So that becomes plus 1,680 over 2. Plus 1,680 over 2. Putting all of this in my calculator, n is going to be square root that. I get 41 minus 1 plus 41 is 40. 40 over 2 is 20. So n equals 20. So n is equal to 20. That's the final answer. N equals 20. Of course, you could have been trying values from 15, 17, 18, 19 until they get 420. You could have just used trial and error. All right, but it's easier this way. So n is 20. Nice and easy. Now, finally, it says write a simplified algebraic expression for the number of dots d in figure n. We done that already. We said that the number of dots in a simplified expression is a half n squared plus n. A half n squared plus n. We already filled out that part of the table, so good. Now it says, show that there is no diagram that has exactly 1,000 dots. So that means that you can never find a value for n that will have 1,000 dots. So when you set a half n squared plus n, when you set that equal to 1,000, when you set it equal to 1,000, you're not going to get no integer value for n. So let's see. We'll multiply through by 2, we're getting n squared plus n. And then we can bring over that 1,000 times 2 to get minus 2,000. This is equal to 0. All right. Again, to solve these equations, just go straight to quadratic formula. Using the quadratic formula, we're going to get that n is equal to minus b, which is -1, plus or minus the square root of b squared minus 4ac. So it's plus or minus the square root of b squared, which is 1, minus 4 times 1 times c, which is plus 8,000 over 2. So when you do that and you do the division, what are we going to get? We're going to get minus 1 plus the square root of 8,000 over 2. You're getting 44.2. You're getting n equal 44.2. Now, if you're getting n equal 44.2, this is not a whole number. This is not a whole number. This is not a whole number. And so clearly, no diagram. So hence, no diagram has 1,000 dots. N has to be a whole number. All right, because you can't draw a shape with a quarter of a side, right? You cannot draw a shape with a quarter of a side. So that's all we're saying. 44.2 is not a whole number, and so no diagram has exactly 1,000 dots. Nice and easy, soft. Question 9.